Today's topic is synthetic division. Our essential question is, how do we use synthetic division to divide polynomials? What most of you are going to find out is that synthetic division is a shortcut for long division. But the divisor has to be of the form some number x take away k. K is just going to be some constant number, but it must be in this format, otherwise you can't use synthetic division. And the reason that it's a shortcut is because you only use the coefficients of the polynomial to help you to do it. So let's go ahead and jump right into an example, and we'll show you what it looks like. So in example 1, we want to use synthetic division to divide the following polynomial. 3x cubed minus 17x squared plus 15x minus 25. We want to divide that by x minus 5. So the first thing we're going to do is note that this is in the proper format. We're dividing by a binomial x minus 5. So it's in the proper format, so we are good to go. Okay, notice there's no coefficient in front of the x. If there is, we have to get rid of it. So this one is good for synthetic division. So the way that we set it up is we use this little marker, and then we're going to pick out all of our coefficients. Now before you do that, make sure all your terms are present. That's always a question you have to ask. Do I have all of my terms, and are they in descending order? So it starts with cubed, it goes to square, it goes to x to the first, and then we have our constant term where there is no x. So this is in proper order, and all the terms are there. So now that I've done that, now I'm going to go back and I'm going to take all of my coefficients, and that's what I'm going to work with. I'm going to keep them in this order, so I just write them down. 3, negative 17, positive 15, negative 25. Okay. Next thing I'm going to do is figure out what I'm dividing by. It's always the opposite of whatever this number over here is. So we're going to do since it's x minus 5, we're going to take the opposite of that, which is a positive 5. And that's going to be our divisor. Now, I'm going to leave a little bit of space because we're going to be filling things in here. And I'm going to draw a nice little line all the way across. And right at the end, before the space underneath where that last term would go, I'm going to put a little line. What goes here at the end is always going to be my remainder. So I'm going to put a little line there to show that this is where the remainder goes. Alright, here goes the steps. First step, bring the first term down. So the 3 comes straight down, write it underneath the line. Now take that 3 and multiply by the 5 that is our divisor. So 3 times 5 is 15. You're going to write that underneath the next term. So I now have 15 written underneath the negative 17, which was my second coefficient. Now I'm going to add those two numbers together. 15 plus a negative 17 is a negative 2. Bring that down. Now I take that negative 2, I multiply it times the 5. And I'm just going to keep repeating this process until I get all the way to the end. So negative 2 times 5 is negative 10. 15 take away 10 is 5. 5 times 5 is 25. Negative 25 and positive 25 is 0. Whatever you end up with as this last number is your remainder. There's nothing else to do. We're finished. Now, once you've gotten all of these numbers, the next thing to do is, if there's no remainder, then that means that x minus 5, the opposite of this, x minus 5, is going to be a factor or a root. Okay, just like in long division, if we ended up with a remainder of 0, then we ended up with calling it a factor or a root. So again, that last number is my remainder. Now the rest of them are my new coefficients. So these are the new coefficients for my new polynomial. Now you'll notice that there's only 3 of them. Up here we had 4 of them. So it's always going to go down by 1 degree. So because it's going down by 1 degree, that x cubed is now going to be an x squared. So the 3 is going to go on the x squared term, and then we just go down by 1 degree for each of the remaining numbers. So 3x squared is my first term, negative 2x is my second term, and then plus 5, notice no x because we've gone down in degree. And then we had no remainders, so this would be my quotient. You could do the same problem using long division. It just takes a little bit longer, so that's why this is a shortcut. Let's go ahead and pause, write down your results, and we'll pick up on the next example. So example number 2. Use synthetic division to divide the following polynomial. Got 9x cubed minus 16x minus 18x squared plus 32. We're dividing that by x minus 2. Alright, so just like before, our first step is to make sure it's in the proper order and all the terms are there. You'll notice that these two need to be switched because they are not in the proper order. Descending order would be 9x cubed minus 18x squared minus 16x plus 32. And then again, we're dividing that by x minus 2. Now that I've gotten it into descending order, and remember, the sign that's in front of it goes with it. So that minus 18, that minus went with the 18, that minus went with the 16. Now that I've put it in descending order, now we're ready to set up the problem. So we're dividing by a positive 2. We are using 9, negative 18, negative 16, and 32. So 9, negative 18, negative 16, and 32. Draw my line, put my little marker for my remainder area, and we're ready to go. So again, step 1, bring down your first term. So bring down the 9, multiply 9 times 2, 18. Combine the 18 and the minus 18, you get 0. 0 times 2, we get 0. Negative 16 plus 0, negative 16. Negative 16 times 2, negative 32. Negative 32 plus 32, 0. So once again, we have a remainder of 0. So that means that x minus 2 is a factor of this polynomial, which means it will also be a root or an x-intercept, 0, etc. Alright, let's go ahead and finish writing out our polynomial, which will be our answer. Started with x cubed, so we're going to go down 1 degree, so 9 will now be my coefficient for the x squared term. 0 will go with the x term, and minus 16 is my constant term. Now this can be simplified, and if you were looking at it on a test situation, you would see it as 9x squared minus 16 would be your answer. Okay, pause and record. We'll move on to the last example. Okay, third and final example. 5x cubed plus 6x plus 8. We're dividing by x plus 2. So once again, check to make sure all the terms are there. One of them is missing. Which one's missing? You are correct. The x squared term is missing. It is imperative that you put 0x squared into your problem before you start setting it up for synthetic division. You will miss the question if you do not put that number in there. Because remember, I'm basing it on coefficients, and if that 0 is not there, everything's going to line up the wrong way and you're going to get the wrong answer. We're going to be dividing by a -2 this time because we want to do the opposite of it, so we'll be using -2. So let's go ahead and get this set up. So inside of here, we're going to put -2. My coefficients are 5, 0, 6, and 8. So 5, 0, 6, and 8. And now we're ready to get started. Bring down the first term. So write down your 5. 5 times a -2 is a -10. Add these two numbers together. 0 plus a -10 is -10. Multiply. -10 times -2 is a +20. Add these two numbers together. 20 plus 6 is 26. And multiply. 26 times a -2, we get -52. Add these last two numbers together. -52 and 8 would give me -44. And you'll notice that this time we have a remainder. So what does that tell us about x plus 2? If you said that x plus 2 is not a factor, you are correct. Because it does not go in there cleanly, because I've got a remainder, x plus 2 is not a factor or a root of this polynomial. Now let's go ahead and write our final answer. Again, we went down by 1 degree, so my answer is going to be 5x squared minus 10x plus 26. And then I want to go ahead and tack on that minus 44. And just like in long division, we put the 44 over what we were dividing by, not just the -2, but the entire binomial, which was x plus 2. And this is our final answer. Go ahead and finish copying it down, and we will see you tomorrow in class. Have a good evening. Bye-bye.